Hello everyone, welcome back to my channel Step by Step. One day Gullu came to me and asked me one doubt.
In the series of steel structure, we have used I-shape section as beam and column. I have designed the car shed and electric pole using I-section. But why only I-shape steel section we are using in most of the steel structure? Why it's that much important? What is the logic behind creating I-shape?
That's the good question. Okay Gullu, tell me, you have seen the first video of steel structures regarding the basics of steel structures. And I have explained the very brief description about the physical properties of steel plates. Tell me what you learned in that.
I learned that steel plate has two-axis bending. In major axis, due to its high depth it has very good bending strength. And, in minor axis, due to its less thickness it has very less bending strength.
Correct. You see, in all the steel industry, all the steel members has to bear three major kind of forces. That is bending, shear and axial. Let's check this steel plate is capable of bearing all these three forces. First one is bending. If you see, it has a very good bending strength in the major axis and very less bending strength in the minor axis since its depth to thickness ratio is very large. Second is shear. If you apply the load along the depth, then it has a very good shear strength. But if you apply in the lateral direction, then it has also some issue. It has a very less strength in that direction. And the third is axial. In axial, there are two kinds of forces, axial tension and axial compression. In axial tension, it only has to deal with the total gross area because the plate will fail only in the yielding. But in axial compression, it may also fail in buckling. So this plate has two major limitations. First is bending strength about minor axis is very less, and second, in axial compression, it has the possibility to buckle. What if we increase its thickness also? So let's try keeping this thickness equal to the depth. Means it is going to be a square section now. Now, this square section has a very good strength in bending both in major as well as in minor, as well as its buckling strength also becomes very high. But just see how much cost it is increasing. Let us consider one simple example of a steel plate. If we take the depth of the steel plate as 100 mm and thickness of 10 mm of total 5 meter length, and we'll take the density of steel as per IS 800-2007 clause number 2.2.4.1. It is around 7850 kg per meter cube. So let us check what is the total weight of the section. So its total weight is coming around 39.25 kg. And if we check what is the total cost of this as per the market, if we see, let us take 50 rupees per kg, then total cost of this steel plate will come around 1962.5 rupees. Now if we make this steel plate as a square section, means its depth and thickness is equal to 100 mm and its length is 5 meter, then its total weight will be around 392.5 kg and its total cost will be around 19,625 rupees. So you can see that just to increase its bending strength in minor axis, we have to pay around 10 times. Is it worth as an engineer? Since we are an engineer, not a labor, so we always have an alternate solution for that. We just have to increase its bending in minor axis and prevent its buckling. We can do one thing. We can put another plate oriented in another direction. Since its strength is in major axis, so we are using its strength for the weakness. Now this shape can easily resist bending in both axes. But there is one small problem with this. Since the depth of the member is around 100 mm and if you want to connect this with the bolts, then there should be enough spacing for the bolts. So as of now here in both the side only 45 mm space is available. So more than 12 mm bolt size we can't use. So what is the solution for that? Here we have two options. Either we have to increase the depth of the first plate to accommodate the bolt inside that. And the second option is we have to change the location of the another plate. Since we have connected this at the center, now we can connect this at the edge of the plates. So here the first option becomes the T section. Here we can connect bolt on both the side of the plate, and this can transfer more forces. And the second option, that becomes the angle section, and to transfer the less forces we can use this second option. Now here we have two sections ready with us. One is the angle and another is the T section. Now if we take the angle section as a unit section, then if we want to increase the capacity of this section further, we can attach one more angle section as a mirroring it. So now it becomes our channel section. So if we want to increase our bending strength in both the direction, then we can use this section. Now if you want to further increase its bending strength in both the axes, then you can attach one more channel section to the back side of this. So overall it will become an I section. Now this I section will have nearly double the bending strength in both the axes. So in this way we started from steel plate, then we go up to angle section, then we reach to T section, then from there to channel section, and finally we reach to I section. Hence, as per the requirement that how much force we have to transfer from one member to another, these all shapes of the section we can use. So this is the logic behind creating all these different shapes for the steel members. So if you like the technical reasons behind all the shapes of the steel members, then like, subscribe and share it to your colleagues. We will meet in the next video. Thank you for watching.